So now that we have created the equations by looking at word problems, we need to know how to solve the problems now, how to solve a system of equations. So that's what we're going to do today, solving systems of equations by graphing. There's several different ways that we can do it. We can graph them, we can use algebraic methods, we can look at tables, but today we're going to go over how to do graphing. So let's go ahead and take a look at an example. Negative 2x plus y equals 1 and negative 4x plus y equals 3. So this is a system of equations. We have two variables and two equations. Now when we are graphing, I'm going to have you guys graph on the graphing calculators, and tomorrow we are going to do a calculator lab so that you guys learn how to use them, and so it'll be useful on the ACT. But in order to use the calculators, we have to put it in slope-intercept form, the y equals mx plus b form. So let's go ahead and do that. This should be a refresher. So if we want to put them in, our goal is y equals mx plus b. So let's look at the first equation. We have negative 2x plus y equals 1. And we want it in y equals mx plus b. So we look at the side with the y, because we want to solve for y, correct? And this negative 2x is hanging out with it, and we want that to go away. So to get rid of that, we add 2x to one side. What we do to one side, we got to do to the other. That goes away. Y equals 2x plus 1. Boom. That's in the correct form. Now let's do the other equation also. So the other one is negative 4x plus y equals 3. And in order to get that into y equals mx plus b, we look at the side that has the y. This negative 4x is hanging out with it, so let's get rid of that. So in order to get rid of that, we need to add 4x. What you do to one side, you got to do to the other. That goes away. Y equals 4x plus 3. Boom. So now we have both of our equations in slope-intercept form. So even though we have two equations, we just go ahead and graph them individually. So let's start with the y equals 2x plus 1. I went ahead and graphed this on my computer, and so here's what we get. We get a graph that looks like this. It goes through, the y-intercept is 1, so it goes through y equals 1 here. And then a slope of 2, so you go up 2 over 1, rise over run, boom. That's our equation right there. And we've been talking about what the solution to an equation looks like. And so let's look at this graph. So when I'm talking about my solution or solutions to this equation, we are talking about any point on this line that satisfies this equation. So anything along this line is a solution to this equation. And then when we graph our other equation, y equals 4x plus 3, we get a graph that looks like this. We know that this is right because the y-intercept is 3. So it's going through the y-axis at 3. And then the slope is 4, which is 4 over 1, rise over run. So if you start here, you start at your first point, go up 4, 1, 2, 3, 4, over 1, boom, it goes through. Again, when we're talking about the solutions to equations, if we're looking at the solution to this equation, it is this line. It is any point on this line, because you take perhaps 1, 6, that's that point right there, and plug it into your equation, you get that the left-hand side will equal the right-hand side. And when we graph them, they're going to go on the same coordinate plane, so the same x and y axis, so that we can look and see where they intersect. So we have both of our equations here. We have y equals 2x plus 1 and y equals 4x plus 3. We've been talking about what the solution to a single equation would be, right? So the solutions to this equation would be this line, and the solution to this equation would be this line. And now that we have a system of equations, the solution changes a little bit. The solution is now the point that they intersect. So the solution to this system of equations right here is going to be the single point that they intersect. Because if you notice, this line and this line only intersect right here. So that is the solution, and there is only one solution. On your calculators, there is going to be a way that I will show you how to find the intersection point of those two lines, which gives us the solution. My program on my computer is a little bit different, but here's basically what it's going to look like. Is it's going to give you your x-coordinate and your y-coordinate of where they intersect, which right here the value is -1, -1. So this is saying that our solution is -1, -1. Since we only have one solution, we call this independent. We would label this system of equations as independent. Now, it's important that we check our answer to make sure that it's correct, because sometimes when manipulating equations from standard form to slope-intercept form, you might have made a mistake. So you want to make sure that our solution that was given to us from the calculator actually is true. So we want to take the original equations that we were looking at from the problem and plug this point into them to see if we get a true statement. So let's take the first equation, -2x plus y equals 1, and plug our points in. So we have -2. Our x value is this one, so we'll plug in a -1. Then plus our y value, which is this right here, so we'll plug in a -1, equals 1. So now we simplify the left-hand side. We're checking to see if this is right. So we have a -2 times -1 gives us a +2. Then plus a negative is really like saying -1 equals 1. Is this true? 2 minus 1 is 1. 1 equals 1. Boom. That's true. We know that. So let's go ahead and go to the other one. So -4, plug in our x value times -1, right? Plus our y value, which is a -1, equals 3. And so we go ahead and solve this. -4 times -1 is a +4. Plus a minus is -1 equals 3. 4 minus, we're seeing if this is true, right? 4 minus 1 is 3. 3 equals 3. Is that true? Boom, that's true. Good. So that is the solution to our system of equations. Let's go ahead and look at another example. And we have 3x plus 2y equals -2, and -3x minus 2y equals -6. So we want to first change them into slope-intercept form, because that's the only way that your calculators will take a equation. So if we take the first one and turn it into slope-intercept form, we get y equals -3/2x minus 1. Then if we take the second equation, we get y equals -3/2x plus 3. You can go ahead and check that math on your own, but for time's sake, that's what it is. So I went ahead and graphed both of these equations, and if you notice, we have the first equation, the y-intercept is a -1, so it goes through -1, and the second equation, the y-intercept is +3, so it goes through y equals 3 right here. And if you notice, they are parallel, right? They're not intersecting at all. So what does that tell us? What does that tell us about this situation? It tells us that these are inconsistent, is the vocabulary word. So we have inconsistent, which means there is no solution to this system of equations. No solution, because they do not intersect anywhere. Therefore, there are no coordinates that satisfy both of these equations. There are no coordinates. And if we take a look at these equations right here, what do you notice about them? Well, I notice that the slope is the same. The slope is the same in both of the equations. The only thing that's different is their y-intercept. So what that tells me is that they are the same line, just shifted, just translated up a little bit. And so, of course, there's definitely not going to be any solution. So if you ever see a system where the slope is the same, it's going to be inconsistent. It's not going to have any solutions. For this section, we have some vocabulary that's going to help us identify our systems of equations. So we have inconsistent, consistent, independent, and dependent. So it is your homework now to figure out what these mean and write definitions, and I'll be checking them for the homework tomorrow.